So hey there, welcome back to another video of Gujarati AI YouTube channel. And in this video, we'll be talking about what is image processing, overview, applications, benefits, and more. So starting out the video, deep learning has had a tremendous impact on various fields of technology in the last few years. One of the hottest topics buzzing in the industry is computer vision. The ability for computers to understand images and videos on their own, self-driving cars, biometrics, and facial recognition are all rely on computer vision to work. At the core of computer vision is image processing. So, what is an image? Before we jump into image processing, we need to first understand what exactly constitutes an image. An image is represented by its dimensions, height, and width based on the number of pixels. For example, if the dimensions of an image are 500 cross 400, width cross height, the total number of pixels in the image is 2 lakh. It's simply like 5 into 4 and 5 zeros. So this pixel is a point of the image that takes on a specific shade, opacity, or color. It is usually represented in one of the following. The first one is grayscale. A pixel is an integer with a value between 0 to 255. 0 is completely black and 255 is completely white. RGB, a pixel is made up of three integers between 0 to 255. The integers represent the intensity of red, green, and blue. RGBA, it is an extension of RGB with an added alpha field which represents the opacity of the image. Image processing requires fixed sequences of operations that are performed at each pixel of the image. The image processor performs the image sequence of operations on the image pixel by pixel. Once this is fully done, it will begin to perform the second operation and so on. The output value of these operations can be computed at any pixel of the image. So, what is image processing? Image processing is the process of transforming an image into a digital form and performing certain operations to get some useful information from it. The image processing system usually treats all images as 2D signals when applying certain predetermined signal processing methods. Types of image processing. So there are five main types of image processing. The first one is visualization. Find objects that are not visible in the image. Recognition. Distinguish or detect objects in the image. And the third one is sharpening and restoration. So create an enhanced image from and the original image. The fourth one is pattern recognition. Measure the various patterns around the object in the image. The next one is retrieval. Browse and search images from a large database of digital images that are similar to the original image. Now let's have a chat about the components of image processing. The first one is computer. A general purpose computer, which may be anything from a PC to a supercomputer, is used in an image processing system. Sometimes specifically built computers are utilized in specialized applications to reach a specified degree of performance. Hardware for specialized image processing, it compromises the digitizer and hardware that can carry out basic operations, including an arithmetic logic unit (ALU), which can carry out a simultaneous arithmetic and logical operations on whole pictures. The next one is massive storage. In applications involve image processing, the skill is essential. The three main types of digital storage for image processing applications are as follows. Three types of storage exist. The first one is short-term storage. Second one is online storage for quick recall, and the third one is archive storage, so which is characterized by rare access. The next one is camera sensor, so it alludes to perception. The image sensor primary function is to collect incoming light, transform it into an electrical signal, which is start signal, and then output it to supporting electronics. It consists of two-dimensional array of light-sensitive components that they convert photons into electrons. Images are captured by equipment like digital cameras using image sensors like CCD and CMOS. Two components are often needed for image sensors to collect digital pictures. The first is an actual tool sensor that can detect the energy emitted by the object we want to turn into an image. The second is a digitizer, which transforms a physical sensing device output into digital form. The next one is image display. The pictures are shown. Fourth one is software. The image processing software comprises specialized modules that carry out particular functions. The next one is hard copy equipment. So laser printers, film cameras, heat sensitive equipment, injector printers, and digital equipment like optical and CD-ROM discs are just a few examples of instruments used to record pictures. The next one is networking. So to send visual data through a networked computer, it is a necessary component. The most important factor in public picture transmission is bandwidth, since image processing applications require vast amounts of data. So let's talk about fundamental image processing steps. So the first one is image acquisition. Image acquisition is the first step in image processing. This step is also known as pre-processing. And Image processing, it involves retrieving the image from a source, usually a hardware-based source. Image enhancement, so image enhancement is the process of bringing out and highlighting certain features of interest in an image that has been obscured. This can involve changing the brightness, contrast, and etc. The next one is image restoration. So image restoration is the process of improving the appearance of an image. However, unlike image enhancement, image restoration is done using mathematical or probabilistic models. The next one is color image processing. So color image processing includes a number of color modeling techniques in a digital domain. This step has gained a prominence due to significant use of digital images over the internet. So wavelets and multi-resolution processing. Wavelets are used to represent images in various degrees of resolution. The images are subdivided into wavelets of or smaller regions for data compression and a pyramidal representation. The next one is compression. So compression is a process used to reduce that thing. So that was all for this video. Thank you for watching.